We're going to move right along here to our next speaker. His name is Venkatesh Chari, and he is the Chief Technologist of Orbit Research. Thank you so much. Venkatesh, it appears that you are still muted. While he is getting his mute situation taken care of, I did want to share, we had a request from Mahadeo to share the link for the idea STEM. Mahadeo, if you wouldn't mind sharing that with me, I can distribute that to everyone to make sure everyone gets a hold of that. Thank you. So Venkatesh, if you're ready now, you can go ahead and share your video. And
all right.
Thank you.
Okay, let me try to do that. I thought I had it all set up, but clearly that wasn't the case.
No problem.
Is this all right?
Yes, we can see you now. Thank you.
All right. Hello, everyone, and my apologies for the little glitch in technology here. Welcome to this session about the Graphiti dynamic tactile graphic display and its applications in inclusive education. At last year's SciAccess conference, Ken Perry had provided a great introduction to the Graphiti. So I'll describe it in brief for those who may not be familiar with it. And then I'll talk a little bit about the applications that we have been working on with the Graphiti. So the Graphiti is, and I'm showing a slide that is a picture of the Graphiti, and I'll describe it. It is roughly the size of a laptop computer, about 1.5 inches in height, and is composed of an array of 2,400 independently refreshable pins organized in 40 rows and 60 columns. The pins are driven by the Tactile technology that we have developed at Orbit. And the most unique feature of the technology is the ability to set each pin to different heights, and that the mechanism consumes no power once it has reached its new position. By the way, in that process, I forgot to really describe myself. I'll do that at the end if you folks don't mind. The multi-level capability of the pins also allows the display of topographical maps and other graphical elements such as shades and color to be shown by varying heights of the pins. The unit also has a braille keypad, which is composed of 6 Perkins-style keys, so that users can enter text, search for files, manage files, even enter text in braille. It also has an SD card slot, and through which you can load pictures into it, a USB host port for loading pictures, and also an HDMI port, and we will be talking about the HDMI port as well. So for viewing graphics, the whole purpose of this product is a terminal device, a device to view graphics. That's what it's intended for. So it has various functions that would allow easy viewing of graphics, such as panning around a picture, zooming into it, applying different filters to process images, and I'll show some effects that use filters, and also to invert graphics to make them more user-friendly. So all common file types are supported natively, so BMP files, JPEG files, etc. And it can also display system messages in visual fonts in addition to braille fonts. It also has a draw mode. So the entire panel is a touch screen, and you can draw on it with your finger. You can erase, you can save, you can edit pictures that already exist, and you can zoom and pan within them. So for connecting to other devices, which is where most of its power is derived, the product has 3 different interfaces. It's got HDMI, it has Bluetooth and USB, and in the future we'll also have Wi-Fi available. So the big news for this year is that this is now a product that is on the market. So we have launched it, it is in production, it is available for ordering, and we're taking orders. We are building relatively small quantities at a time, but they are available, and depending on the availability of stock, They ship in 1 to 8 weeks, and we've had a lot of interest since we announced availability during season time earlier this year. And obviously, this takes on special meaning in these situations where distance learning has become a necessity. So now I'll show some examples of the kinds of things that we have seen people do, and this is only a sampling of the examples. There is actually a lot of different things that can be done, and it's really exciting for us to see the kinds of applications that people come up with. So I'm going to run through relatively quickly through these slides, and I'll try to describe them. I'll make them available later with text descriptions as well. So this here is an application in chemistry where a student at the University of Delaware studying computational chemistry wanted to visualize a protein molecule that the lab was working on. So this picture here shows a 3D printed model of the protein molecule, as well as 2D representations, which were then represented on the graffiti and actually produced a 3D effect with the multi-level pins that the graffiti has, where the parts of the molecule that were closer to the viewer were higher in their level, and the parts that are further away were lower. It's a very, very effective tool, and the big advantage is the real-time rendition of these 3D pictures. So it really lends itself to experiencing live events. Here I have pictures of the total solar eclipse of 2017, where we had a camera connected to the graffiti, and people could visualize in real time the crescent of the sun as the moon occluded it. And it was really the first time in history that visually impaired people were able to witness an event like this in real time, live. On the next slide, I have a video that shows a recorded version of the solar eclipse. It is being shown on a monitor, and to the left of it is a graffiti which is following in the time the motion of the moon across the sun, and showing progressively smaller crescents of the sun until it is fully occluded. So the real-time aspect and the ability to instantly see any event is pretty dramatic. And last year, for the first time, astronomers captured a picture of a black hole, and we were able to show that immediately. We were able to see that immediately rendered on the graffiti. And here I have a picture showing how the graffiti shows the image of the black hole. And through its zooming and panning features and its image processing filters, you can choose the appropriate filter that maps most appropriately to that particular image. Not all images are equal, as some of our previous presenters have mentioned today. And the image processing filters built into the graffiti help with that. But there's room for more filters to be developed, and also for processing to be done on a computing platform rather than on the graffiti. The next example shows a picture. Again, most of these pictures are simply images that were brought up on a Google search. This shows a picture of the ISS, the International Space Station, with the Earth in the background. And I'm showing two images on the graffiti. One, a close-up of the International Space Station, and the other one is a picture which also shows the Earth. And this next slide shows the transit of the space station across the moon. And the graffiti shows this pretty clearly, and zooming in, one can even see the detailed features of the space station. The next slide shows the transit of the International Space Station across the sun. And the background of the picture is similar in color to the sun. However, the bright edge of the sun is clearly visible in on the graffiti, and can be, the space station, of course, can also be seen. So one can explore various images and pictures in real time, but one can also explore concepts. So this here is a picture of of planetary motion. This is actually a video. So one can observe a video in real time and with planets and other objects moving and at a speed that one would want. One can slow down the video, one can see how objects move, and planetary motion is just one example. This next picture, again, kind of going with the astronomy and space theme, is a picture of the Crew Dragon docking with the International Space Station. So this is very, very recent, as I'm sure you know, and it shows the Crew Dragon approaching the space station with its nose cone open and just about to dock, and the graffiti has rendered it fairly well with all the main features very clearly visible, and zooming in again can allow a user to see all the detail. So there's the possibility of live interaction with the unit. And here I'm showing an example where a Tetris game has been coded using a Python script, actually by Ken Perry. And here you can actually see that the user is playing it, actually this is Ken as well, in real time. And this is just one example of the kinds of interactive actions that are possible using the touch screen as well as using the keypad. This slide describes some of the uses with the Orion TI-84 Plus for math. So the Orion TI-84 Plus talking graphing calculator is a product we had developed about 8 years ago, and it connects to the graffiti, and whatever are the contents of the screen are instantly replicated on the graffiti. And here you can see a screen which is actually displaying equations in text. And on the next slide, I'm showing a graph of a function which you can see the function plotted on the screen of the TI-84, and it is replicated exactly on the graffiti. The multi-levels allow us to have the axes be represented at different heights relative to the actual equation, and different equations can also be shown at different heights. So here you can actually see two equations, and they are at slightly different heights. The applications are really almost limitless, and here is an example of the Rosetta Stone, where the symbols of the Rosetta Stone, this is an interactive Rosetta Stone Explorer on the internet, and on the graffiti, we can see the symbols being shown fairly zoomed in, but one can zoom in and out and pan back and forth. In fact, we know of a student who is studying ancient scripts using the graffiti. So in the classroom, the graffiti can be hooked up over its HDMI port. By the way, all the pictures that I described before were all taken using the HDMI connection. So the HDMI connection just makes it an external monitor, and this allows whatever you view on your computer or smartphone screen, or in fact any source, to be visible on the graffiti. So here we are showing a computer connected, and you can see a picture of our braille display, the Orbit Reader 20, being shown on the graffiti, and it replicates whatever is on the screen. The Windows magnifier can be used as well as any other magnification program such as Zoom Text. And whatever you see on the screen magnified appears as is on the graffiti. So this can also be used, of course, for any device that can produce an HDMI output. So here's an example of a microscope with a specimen of an earthworm, a cross-section of an earthworm. And you can see on the next slide here a picture of a monitor connected to the microscope showing the cross-section of the worm, and the graffiti showing it as well. Now, one of the fascinating applications that Caroline alluded to earlier is CAD, and this is actually showing, I believe, some similar examples where OpenSCAD on the computer connected to Graphiti can allow a designer, a user, to visualize shapes in real time. And these are various examples of two cubes and a cylinder being moved in various ways and being visualized in real time with the Graphiti. Similarly, it can be connected to an iOS device, and this is an example of an iOS device showing different graphics. Finally, we have a program that is available with the Graphiti that runs on a Windows PC today, which is essentially a paint program for blind users. And it allows you to draw shapes like circles, rectangles, move them around, enter text in braille or visual fonts, and these graphics are instantly replicated in tactile form on the Graphiti. You can also interact. What you draw on the Graphiti also appears on the computer screen. These files can be saved and shared instantly in real time with anyone who is connected to that computer. So that was a glimpse of the kinds of things that can be done with the Graphiti. Here I have a set of links to our website, also to our email and our Facebook, Twitter, and Instagram links. Our website is www.orbitresearch.com. You can email us at information@orbitresearch.com. And our Facebook and Instagram links are Orbit Research, and Twitter is Orbit Research 1. I promise to give a description of myself. I'm wearing a black shirt. I am of Asian Indian origin with black hair, of which there's very little left now. And I am really thrilled to be here. Thank you very much, Anna, for the opportunity to speak about the Graphiti.
Thank you so much. We really appreciate that. Venkatesh, there are a few questions for you in the chat, but unfortunately we don't have time to answer them on air. But if you could please open the Q&A and respond to some of the questions via text, that would be fantastic.